So I work predominantly with the federal government, not exclusively, but predominantly. And so a lot of what I'm going to talk about today is experiences gained with working with some of our federal clients. Unnamed, large mainframe systems, many, many years old. And I've also recently encountered insurance companies with the same thing, auto manufacturers with the same kind of situation. So in our industry, there are plenty of people that are needing to modernize their mainframes. How did we get to microservices? This is what we're going to talk about today. So we had the problem, we had to replace an application that processes at peak hundreds of millions of documents a day and billions of documents every single year. Was it possible to do microservices? That was one of the questions, because we were replacing processes that had been optimized over the last 30 years and did exactly what they were supposed to do as fast as they could possibly do it for processing at peak. And we'll talk a little bit about the factors of choosing those. I think, how many people have used microservices? Okay, so a handful. How many have heard of microservices? Pretty much everybody that's used them plus. Okay, great. So what were some of the benefits we were looking for out of microservices? We wanted to be able to do some continuous deployment. Now, our client, just so you know, does not do continuous deployment, but we do in our development environment. So we are constantly doing continuous integration and deployment with our development, and we actually are containerized, even though we don't deploy at a containerized level. And I'll talk in a minute about why we did that. The organization needs to evolve its technology stack. Absolutely. This is a multi-year effort it's going to take multiple years, predominantly because this is a very risk-averse environment. So it will take years to get it all migrated, simply because they won't go for more migrations from the risk that it could introduce. And then, of course, it allows for scalability and improved maintenance. How many people have ever heard the statement that you can never get the performance from a Linux system that you can get from a mainframe? Okay, handful. Okay, so I refuse, anytime somebody says never, I refuse to believe, you can never do something. That's my biggest challenge, and that's the first thing I want to prove, is that that's not true. So, as we were deciding what to build, we had to figure that out. So how did we know what we should build? The first part of our problem was the requirements and the current state architecture. So just like ATAM is used, you guys all know what ATAM is, right? The architecture assessment model that is part of SEI, okay? So we used basically a modified version of ATAM, and we started with the business problem. We got with the business and with the current people that were defining, executing and operating the system, and defined what was the problem space. What did we need to solve, and how many of those pieces did we need to solve? And we started focusing down on a handful that were the first candidates. So a very iterative model, not trying to architect everything, but trying to understand the edges so that we could choose the things that could be strangled out quickly. We defined what the capabilities of the systems were. So we did a full inventory. What is going on in the system? What touches what? What kind of data flows where? And we then documented that. Now, the way we documented that, because I'm very impatient, which is probably why I lost the argument with the boulder, we used pictures, okay? Business process models, BPMN syntax, because we had a very mixed team. We had a full cross-functional team. We had over 40 business stakeholders. We had the existing architecture team for the enterprise. We had a solution engineering team for the enterprise. We had our own architecture team that was doing the assessment, the application architecture and development teams that would be building the results, the testing teams, and operational teams. All of those people were involved in the, shall I say, buy-off on that, yes, we had captured all the information and that we knew what it was going to do and that it would do the same thing, and they want 100% parity in functionality for today and for tomorrow, or for the current state and future state, okay? So we used those pictures. That was the only way we could get everybody on the same page to understand what the subject matter experts knew in their heads. So we worked with subject matter experts. Some of them have already retired. Okay, so there's some places we couldn't work with subject matter experts. You do deep dives into source code. You read any documentation there is, even if it's not accurate. You do your best, and you start building those straw men, and then you start reviewing with subject matter experts. So there is one, for example, there were a couple that we were reviewing with on the first components that we were going to replace. And we would basically gather all the information, think we understood it, and think we understood it was the key there, map it out, give some diagrams, and we would do these in 2-day cycles. So we'd take 2 days, we would show them, we'd have a review, and we'd find those gaps in our knowledge and in the business rules. For every step in a business process, and we had different levels of business processes, so we decomposed deeper and deeper, so you could get down to the level that a developer could actually pick up a diagram and say, oh, I know I need to write 5 methods, and they have to use these kinds of data, these data elements have to be processed in those methods, and here's my calculations that are the business rules that I have to perform, okay? And as we did that and reviewed those, it was very tight iterations. Once we had gotten through that with the subject matter experts, we took those pictures and that great big cross-functional team I talked about, we did walkthroughs. Absolute, total walkthroughs, end-to-end on the process to get buy-off with all 40 business stakeholders. And they actually had to sign documents. Again, this is the federal government, right? They have to sign documents. So we got there. And then we were, and during that time, we're talking to them and understanding the design. And I had one of the owners of the current system say, well, you have to make sure that the code is exactly the same as we do today. And so they're writing in ALC. Anybody ever know the assembler? Okay, mainframe assembly language. And we were rewriting in Java. Okay, so the statement that we have to write exactly the same code to do the same things the same way is just inherently a problem for me. So we talked about that. Over time, though, we said, okay, do you really want us to limit what we can accomplish with Java and in Linux and in the new modernized technologies to the way the system works today? And that argument carried. It's very logical, right? You don't want to limit yourself to what you can accomplish. And at that point, that same person also became one of our biggest proponents and made that mental shift to understand that what we're really doing is decomposing and finding where our seams are. And with those seams, figuring out which pieces of code have to be together and which pieces can be separated. And that was how we started to the definition of where the microservices boundaries were, okay? Those systems also, or those seams also helped us figure out if they had a program that was multi-purpose, where we needed to break it into pieces, or if they had single-purpose apps that really should be combined. So, for example, they had 2 processes that ran in parallel because they weren't able to, at the time they wrote the code, they weren't able to multi-thread very well within their ALC. So what they had done is they'd written step 1 and step 2 of the process as independent pieces so that they could run in parallel across these very large files of documents. So the documents are like XML flat files of records, and each record in the file was a document. So as we looked at those and realized that you could never run step 2 without the data from step 1, never. That's when it became very clear that you needed to combine some things. So those were some of the decisions we were able to do and some of the ways we made those decisions. Prioritizing the changes was important because, as I mentioned before, this is a multi-year effort because they're never going to let us, even if we want to, replace it all in 1 year. They have too much processing every year that's done that they can't risk. They don't want to go to Congress, by the way. They do have to actually go sit in front of Congress if anything happens to processing to cause any stoppages in processing. And they really don't like to sit in front of Congress and be chewed out. So the last thing was understanding the mainframe logic. Because it had been optimized over a 30-year period of time, there were lots of lessons embedded in that code. And we had to sort through those lessons and figure out which ones would help us and which ones were evidence of a limitation within the kind of processing they were doing on the mainframe. So let's talk about how we learned about the mainframe. Annually, 3.5 billion records are processed. So 3.5 billion documents are processed every year. There are 2 or 3 peak days a year where you have approximately 625 million records processed in one day, or million documents processed in one day. So one of the things that we learned from the mainframe is they had sorted all of the data. So all of the incoming documents were sorted in key order to match the key order that was in the reference data, because what this was doing is identity comparisons. So this was identity validation across all of the identities in the documents. So they did pre-sorts because the mainframe reads, all of these are stored on tape, by the way, these are not hard drives. They're all files read from tape. So they have to be read and write sequentially. And that is why they sorted the data. So sorting the data wouldn't necessarily help us because we didn't need to sort the data. In fact, it might be a problem if we sort the data in the file systems we're using because you wouldn't be able to parallelize as much, okay? So that was not something we needed to do. But then we found out how they use that reference data. I mentioned the reference data was sorted, but they also loaded, it's reference data that represents 450 million people loaded into memory. That's one reference set. Then the other reference set is 250 million commercial organizations, also loaded into memory. So that's one of the ways they run very quickly is because they have enormous amounts of memory on the mainframe, and they have it all loaded into memory. So that was one of the things we had to account for. Next, we had to understand that we were also being remote. Okay, so we are not replacing everything in the mainframe. So we actually are integrating these services with mainframe processing. So you go from the mainframe to the Linux processing and back. So we're also introducing network latency. So we actually have to increase our processing capabilities or increase our throughput, right? Reduce our time in order to account for the network latency. So obviously, I think this is probably obvious to everyone, we need a scale-out model because we're going to have to increase our throughput. So our priority quality attributes, obviously performance. We are going to prove everybody wrong, need to prove everybody wrong that you can have Linux systems process just as fast as mainframes. Scalability, it had to be able to scale because that 3.5 billion is not static. That increases every single year and with every single legislation. The number of those documents increases annually. In fact, about 3 years ago, they increased by 350 million. Over the next 2 or 3 years, they are expected to add another 400 to 500 million. So, we're going to be up to 4 billion within a year or two. Okay, and maintainability. So the other part is because this is a single set or group of services that are being built that will over time be connected as more and more pieces of the mainframe are replaced, we have to be able to integrate with other newer services, so they have to be good contracts. Also, the law changes every year, and because the laws impacting this change every year, we have to be able to go in and add business rules as necessary. Additionally, these services had only ever run on the mainframe for 2 or 3 very specific processes, and there was a pent-up demand across the enterprise for all of them to be able to use the services. And in fact, we have deployed them for 3 or 4 other environments now, or 3 or 4 other systems besides the original mainframe system are using them now. So, discovering the legacy APIs. Where were their handoffs of data across the system, and what data was involved in those handoffs? That was the first part of that inventory of the next deep dive. Then, how did we translate those to new APIs? So, on the mainframe, they're using a vSAM flat file data store. we're using an Oracle database. So, and, sorry, the documents coming in through the modernized path are using an Oracle database. These services that we built run fully stateless and have no backing data store. All of the data, all of the reference data is kept on disk and is loaded into memory during operation, or at startup, okay? So we had to figure out what are the new APIs, because we have to have 100% upstream and downstream parity. We have to be able to take the data as it comes in today and be able to spit out all of the same results at the end for all of the downstream mainframe processes to still maintain. And we also are enriching the data from a metadata standpoint. So there's additional data that we're adding in this. The current systems in the mainframe have no historical view. They can run these validations multiple times, but they overwrite all of their history. We've added the ability to keep the history. So for any of the ones that are being stored in the database, we keep a historical view of everything that was executed. So you can also come back and see were things made or decisions made based on faulty data in any way, because these do impact compliance and penalty type processing. And the importance of the documentation. So I don't know about you guys. I have not yet met a developer that likes to write documents. So we actually put all of our diagrams and everything right in the code. So we have documentation as code. And that, I don't remember which tool we're using, but basically it is lines of code at the very beginning of every file, and it will actually generate UML diagrams, sequence diagrams, and class diagrams for us. So when we run our Java doc, it also outputs those diagrams for us. And honestly, it's much better. Now if I'm maintaining a module, I also know what it was supposed to do before I started touching it, and I can either change it or make it work right. So the patterns we used, I mentioned Strangler already. So we do have the legacy mainframe where you've got one application, the data coming into one application will be sent through our Strangler process. We have an API gateway that goes through, that then routes it to the correct services. And then on the back end, some of this actually adapts and goes straight to other services. Some of it comes back through the routers and through the Strangler to the application. So modernized systems here, typically, and legacy systems there, typically, talking to the same systems. Actually, go back. Those microservices, they are JMS interfaces. So everything's coming in as messages. 1 to 100,000 data elements to be validated. And they are supporting it. That same interface is supporting both asynchronous and synchronous traffic on the front end. Our processing requirement, our SLA, is 8,400 executions or validations per second in order to meet the 616 million a day. To start this out, as we started figuring out our patterns, one of the first things we did is we actually did an experiment. I don't know how many people were in James Lewis's presentation about experiments. I advise them for everybody, because there were plenty of unknowns, especially when you're introducing completely new concepts to an organization that is still struggling to have enough Java people. Do those experiments. We did an experiment actually in AWS, and I said I'd mention containers. So what we did is we built a container that duplicated the environment we knew we had to deploy to, right down to the versions of every library and the operating system that we knew we'd have to deploy to. These are deployed in Linux VMs at the client. They are not deployed within containers. So we reproduced the environment so that we could do a full experiment and not have, now I'll refer to someone else's, Bryant. His last name is Bryant. James? No. David, thank you. David Bryant's conversation about mechanical sympathy. That is also a very true thing, because that was what saved us. Having those containers that replicated the environment that we would have to deploy to has been how we've been able to do this at a fairly quick pace. So we used decomposition, and we broke those. There were four activities that were done, we broke into 3 microservices. So 2 of those were the ones I was talking about where you couldn't do B without doing A on any piece of data. We put those together. And then the other 2 were independent. So we have 3 independent microservices for those 4. And then the other one was it's a one-to-one. It was a batch process before, and now it's a microservice. So we ended up with 4 total services that are running as microservices. So that's our decomposition. And no, they are not inventory management, delivery management, order management. Those are examples. Because no, I'm not doing an e-commerce platform. Service independence. We made sure that we segregated those so that they could be deployed or scaled independently, because one of them, if you look at the documents that we're processing, you'll have one entity of one type on every document, but you'll have up to 200 of the other type. So we had to be able to scale one of the services much larger than the other service, and we needed those to be deployable. You know, all the good rules about microservices, they're independent of each other, they have no dependencies, they're stateless, they deploy independently. They also, even though they use the same data sets for reference data, they load their own copies. We are using JBoss Data Grid to load the data into memory. That's our cache. And we're using it in an embedded mode so that there's no network latency to get to the data itself. So I believe that's not library mode. And then I mentioned that it was all messaging. So we use messages between everything coming in is coming messages, and everything going back out is messages for these microservices. Sorry, I had a note I wanted to. Okay, so yes. So full encapsulation of its own data. Every service owns its own data. It has no calls out to any other service. There are no dependencies, and I already mentioned basically that it was separation of concerns. So another recommendation, we actually organized the teams. So we used Conway's Law, but we did it kind of the opposite way, right? So Conway's Law tells us that software represents your organizational structure. So we knew we needed to have these microservices be fully independent. So we organized around the microservices and created teams separate teams to build the microservices. So it's important that that made a difference in the builds, deployments, and transmittals. So basically these are top to bottom, similar to skeleton walking, but much fatter because it's the full service. But it's top to bottom. That team is responsible for every layer or every piece of the service. So that was one of the things that helped us succeed in building those out. We have a CI pipeline, so it's full CI/CD in our cloud environment. Once it moves into our client environment, it is CI with CD to our development integration environment. After that, it's manual deployments into the final test environments in production. And that's because that's the requirements with the client. We're limited. It is the same code. We can build it externally or internally and have the same binaries. We can deploy either set of binaries. So that is reliable chain at that point. Performance and load testing, we use JMeter. Absolutely critical that you do that when you're looking at this kind of high volume processing that you're going to replace, especially with all the naysayers about the abilities of Linux. So we also have a requirement that we have 85 to 90% of test code coverage of all of our system. Unit test, integration test, and end-to-end test. So we have to have, we make sure that we're covering that much of our behaviors. And that's also one of the things that has saved us more times than I can tell you as we've moved code from one environment to another. And then production support and monitoring is something we're working on more. We do a lot of logging, and that logging, so our performance, so this would be kind of, so we could use it for fitness functions. We log when we get a message, We log when we are done processing and handing that message back. So everything that we process, we know our round trip times within our system. We also separate our PII data from our logging information. So we will not log our PII data into the same log file as we log the error message itself, so that we can keep those separated and protected. Okay? Now, not every organization is ready for change. Not every organization will allow you to organize them or organize your teams around the services. So that is one of the things you might need to work on with your teams in fostering these ideals. There are other teams that we support within the same client organization that have decided to organize themselves horizontally, and they are having problems with every build and every deployment because every team, all teams are dependent on every other team. So no one can ever build something independently. The last thing I wanted to mention was what we call functional parity. So there is a requirement that we have 100% of the same results from these processes as the legacy system does today. That is actually one of the reasons why we were why we were requested to build these. There had been an attempt before at building not microservices, but straight up services. They backed themselves with a database instead of a memory cache. So their SLA was a week long with what our SLA will be for a day. So they weren't processing. And they had actually 50% of the business rules implemented that were required. So that was not successful. That quote rewrite was not successful, and that's why we came back. Again, this is especially because of that failure. We all get to live with the previous failures, right? So now they said you can't go to production until you can prove parity. So we've already started parity testing with smaller data sets. This is actually running in production side by side with the legacy system for a year. That's part of the retirement plan. So we will have processed a full year's worth of data side by side with the same results before it basically retires the legacy piece and has fully strangled it out. However, this organization has other pieces they've been building that haven't been retired for 10 years that are supposed to be strangling pieces out. So I figure a year is a good success over 10. Again, risk-averse organization. And that was it. Any questions? I guess I'll give you this. I'll stand behind here.
Okay.
Hi. So on the last slide, you mentioned that you will compare the input and the output. How do you handle side effects, or was there any side effects from like running two systems in parallel with the same input and output?
So the mainframe runs in EBCDIC. So we had to figure out how to do our EBCDIC to ASCII translations. And we're actually doing those on the mainframe so that we're careful. We're doing those within Java. We have a compare utility. We're using the same source files so that we don't actually have to compare the source files because they're the same. But when we drop the results back on, we're dropping them in the exact same format as the current system outputs. So it will actually be a byte for byte compare. So if there's side effects, then that's a bug, and it'll have to be fixed. Yes, please.
So you performed a knife edge cutover, or was it some sort of incremental implementation?
So we've taken it. There are about 80 processes that we're going to be replacing. We're replacing 6 of them first. So not a full cutover. And those 6 will be running side by side, so it won't, still not knife edge. It'll be in parallel, and then it'll be like a knife edge for those 6. Okay.
Okay, more
Any
questions?
other
Okay,
Thank
thank you.